Okay, today we're going to look at some derivatives and we're all going to look at some functions and ways to rewrite functions so that we can find the derivative. All right, the first thing I want to do, I want to look at this statement at the top. If y is equal to x to the n, then y prime is equal to nx to the n minus 1. This is the power rule. All right, it's it's one of the most basic rules of the derivatives, okay? And basically what we're doing is whenever we have a power, we need to multiply, bring it down in front, as you could do with the n, and then subtract 1. Now, what we're doing here is actually the constant multiple rule, all right? But just remember, every time you find the derivative, thing we want to make sure we do is multiply and subtract 1. No matter what, multiply and subtract 1, regardless of what's up here. Okay, so the first thing we want to do, y'all, is look at this function. F of x is equal to 3x to the fifth minus 4x cubed plus 6x minus 5. All right, so the first thing we want to do is let's find the derivative. All right, so the derivative here is going to be f prime of x. And remember, we need to multiply the exponent and subtract 1. So 5 times 3, that's going to be 15x to the fourth power minus 12x squared. The 6x turns to 6. Remember, that's an understood 1. And the derivative of any constant term is 0. So that 5 is just 0, so it's just not there. So that's 15x to the fourth plus 12x squared plus 6. All right, so now we can move to the next one. We have f of x is equal to 2x to the fourth minus 6x cubed minus 8x plus 2. So let's look at the derivative. Okay, multiply and subtract 1. So that's going to give us 8x cubed minus 18x squared minus 8. And remember, the derivative of any constant term is 0. So the derivative of this 2 is just 0. Now, down here, it's a little bit different because we don't have power. So, of course, we can't use the power rule, or in our case, the constant multiple rule, if we don't have powers. So what we want to do is let's just rewrite it and write it in a way where we can use our terms. So the square root of x can be rewritten as x to the 1/2. And 7 over x can be written as 7x to the negative 1. All right, so we have to remember that. That's 7, that's x to the 1/2. Remember, it's under the square, and under the radical, I'm sorry, and then that's 7x to the negative 1. So now we've written it in a way where we can execute our rule. So from here, we're just going to go f of x is equal to 1/2, because we're still bringing that exponent down, 1/2 x to the negative 1/2. Okay, 1/2 x to the negative 1/2. We have to make sure we're able to do that. Now, we execute the same rules. Negative 1 times 7 is equal to negative 7 x, then raised to the negative 2. All right, so that's 1/2 x to the negative 1/2 minus 7x to the negative 2. All right, so that's the way we do that. We basically just rewrite it so that we can use our rules. Now let's look at this next one. We have 18, write it out, I'm sorry. We have 18 divided by the cube root of x minus 12 divided by the square root of x plus 6 divided by x squared. So we just rewrite this one. 18x, that's going to be to the negative 1/3 minus 12x to the negative 1/2 plus 6x to the negative 2. All right. And once we write it out, once again, y'all, we don't change the rules. We don't switch anything up. We're just going to continue to use our rules regardless of how it's written. We may want to make sure we stay consistent. Now remember, we write it as 1/3 and 1/2 because of its position under the radical, and it's negative because it's in the denominator. Okay, definitely have to remember those. So now the derivative here is negative 1/3 times 18. That's going to be negative 6x to the negative 4/3. I'm coming back and writing that. Negative 1/2 multiplied by negative 12. That's going to be a positive 6x to the negative 3/2. And then 6x times negative 2. That's going to be negative 12x to the negative 3. So let me come back. Let's put our exponents back in. That's to the negative 4/3. Remember, no matter what the exponent is, we're not going away from our rules. So we're going to still subtract 1. And we have to remember that. That's going to be negative 3. I'm sorry. Negative 2 minus 1 is negative 3. So this is how we do our basic power rule, constant multiple rule, and this is how we utilize them where we have to rewrite. That's one of the most useful things that we can learn early on when finding derivatives, is learning how to rewrite our functions just to get them on our terms.